toch leuk.
Ja, daar kan ik wel om lachen.
Welcome back.
Dikke stuk maken.
So I was asked to use this microphone. Can everybody hear me?
Yes.
Great. So I was asked to give this talk about Elm and my experiences, and I named this talk Elm from the Trenches. Well, maybe I'm overselling a bit. So basically, this is me sitting on the couch, walking through tutorials with a certain goal. So I'm not a real expert. If you want an expert, there's one in the room who does this in production. I never did this in production, but I did something with Elm, which I'm going to share with you. So Elm caught my attention because there was a conference, Drive Coding, somebody of you went there, and there was announced a workshop called Creating Games with Elm and Cats. So that piqued my interest. But I wanted to come prepared. I hate being the stupidest guy in the room, so I always look up the technology I'm going to use. I did not end up doing the workshop, but I did end up learning Elm. And what I wanted to do was create a game, and this is the game. And some people ask me, what's this game about? Well, you have a circle with colors, and you can rotate the outer disk by pressing a button, like so. And if you do that often enough, then it's back in the original state. And the other thing that you can do is swapping the lower colors. So in this situation, green and red would switch places. So if you do this multiple times, the puzzle, because it is a puzzle, will get mixed up. And the object of the game is to return into the original state of the puzzle. So if I would bore you, you can go play this puzzle on the web, because it's on the web. You have to Google for it, but it's not that hard. And I made this in Elm. So one of the questions I had in the break was, well, I see this light example, and I see this game. How can you use this in production code? And the honest answer would be, I don't know. I didn't do this in production. I know people who do this in production, and I think that there are certain aspects of Elm that will really leverage the technology inside of an existing application. But I'm going to show you that with some code, and I hope we can discuss that later on. So let's go over to the code. So this is probably not very readable, but I'm going to change that in a few moments. So what I have here is a repository of the game that I showed you, and what we're going to do is I'm going to walk you through the code as good as possible as I can. So at the moment, I'm going to put down this mic for a moment.
Still yell.
So this is basically an empty repository. If you create a repository on GitHub, it asks you, do you want to have a README and do you want to have a license? And I click both yes on those. And there's some stuff in there that's left over from a newer commit, but we're not looking over it. So if you start with this, you're all good and nice. So if you ever want to try this tutorial, walk through a tutorial, this is actually what you can start off from. So let's go over to something interesting. So the first thing that I tried to do was use npm to use Elm, which works, but I just ended up installing the Elm installer. You can run the reactor if that means anything for you. So I ended up eventually deleting this as well. But I wanted to show you that you can rely on technologies without, probably, who uses Node in production or uses Node somewhere? Yes, if you use Node, then you can use Elm without intrusion. Just you include a dependency and then call some scripts and it will work for you. So that's one step I tried, which works. But again, this is still not Elm. I'm going to show you Elm code now. So this code, now it's possible to see something, which is an actual file with Elm code. And with the introduction of Mats, you're all experts in Elm now, or at least you can read this. And although this could look daunting, I will increase the font a bit. Sorry. At least you know that because of the Elm architecture, there are some certain points that you can recognize. So I have a very similar calling method, the main method, which is a beginner program with a model and a view and an update, which you can reference in some kind of way. And in a sense, there's a model section which actually has a comment, which has model, which defines what the model is. And this is one of the interesting points for me, is that you know where to look if you want to change things. So if you want to change the view of something, you go over to the view side. If you want to change the way that the Elm program reacts upon your messages, you go to the update method. Or if you want to change the model itself, then you're going to change the model. So that's a very big plus. So what's the model in this situation? Well, I'm going to model that puzzle as a list of integers. You can read the annotation yourself, in the sense that if the puzzle is in its initial state, it's just the list of integers 0, 1, 2, 3, 4, 5. And what you do if you rotate the disk, it's just rotating the numbers and doing that. So I'm going to walk you through some of these methods or functions that I created that do these. And this is just functional programming, which allows you to focus on one single thing, implement that in terms of other functions. So it's not that hard, or at least I don't think it's really hard if you've known this word. So I create some helper functions like the range. Will set up the initial list. So the range from 0 to 6 will do 1, 2, 3, 4, 5. And that's implemented with the sequence function. So this is basically me trying out the language and writing down the functions that allow me to express the problem. So if you have any questions when reading this code, ask them now.
Can you explain the model a bit more? Because there's this outer ring and this
Yeah.
inner ring, and how does that translate to the list of integers?
So if you look at the puzzle, so the inner ring is just for your visual reference, that you know which color need to go where. So that doesn't change at all.
Okay.
And the outer ring is just actually the
I
list.
misunderstood the inner ring not changing.
Okay. So the inner ring is just for a reference. You know that the blue segment should go on top like this. So now the blue segment's in the correct position. You need to reorder the others. Is that correct? Okay. So so this is just basic. You have a problem you need to fix. I want to rotate a list of things. How do you do that? Well, you can think about that yourself. And one of the nice things is that you can do higher order things in a functional language. It's like an inverse rotation is actually take the permutation that you have, take the list of integers, reverse that, and then rotate it, and then reverse it back. So if you think about it hard, which I did, this will work out. You can see it. So these are just all nice functions that do things, which is nice because what we now have done is we model the problem by just creating functions that work on the model, and then we know if we can test it that it works. So that's one part which I really like. You can focus on things and then later on figure out how to view these things. So here's the update message. There are a few things that you can do with the model. You can rotate it, you can do an inverse rotation, or you can do a swap, and swaps the lower part of the and this is just change the model accordingly to the corresponding function. And this, again, if you've seen the introduction, isn't rocket science, because this is just how Elm creates applications. And the view part is a bit more involved, but again, it's not that very, very interesting in the sense that you just need to show something. And there are two things here. I started out with just listing the permutation and seeing, is this the list that I expect? And then later on, I introduced SVG, so scalable vector graphics. And I really like that, because you can focus on the fundamentals of something, you have a feel of what the model should be, and then later on you can expand on that model without changing the model itself or the update functions. You can just add another view of the same model. So that's very nice. And one of the things that I really, 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 really like is if you look at the view permutation as SVG. So it seems as though that you're actually creating some sort of HTML inside of your source code, but it's not. So Mats got over this as well. So what actually these are functions which will under the covers create your HTML for you and update your HTML for you, and I really like that. So one of the things that I have done often in JavaScript, and I'm a guy that likes JavaScript, so I'm a bit crazy. But one of the things that I always do is if you do SVG by hand in JavaScript, you always end up doing some curve calculations and you need to concatenate strings, and it's just very messy. And with Elm, you can do all these calculations on the side and have a type-safe system. So that's really nice. Or I really like that. Have I told you that I'm a little bit crazy because I do JavaScript by hand? Yeah. So that's one of the other reasons that I like Elm as well. So Elm allows you to do coding, have sanity as well. Because in JavaScript, like undefined is not a function is actually a real problem, which you often see. Again, and this is the example of creating a segment, a colored segment. I can do all these calculations. Where do I need to place my points? I can always and do this on the side, literally on the side, and then concatenate those in a type-safe way, and I know that this will work. Are there any questions on this code?
Yeah.
Yeah.
Can you scroll back to this? It's a side question and it's about syntax. So I just trying to understand what's going on. Yeah, when you have this SVG, working. Yeah, here on this screen, it's now in the bottom part of the screen. You have SVG, and then you have something that looks like a list.
Yes.
Then you have this white, and then string, height, then string. What? It looks like a function invocation. If I understand correctly, it's white, then space, and 480. What's the syntax? Can you explain?
So basically, if you do any HTML, and SVG is an example of that, what you actually are going to do is you're going to call a function which will create an element on the HTML page. So the svg.svg is a function that will eventually create HTML. And then there are two arguments which are both lists. And the first lists are going to be the attributes of the HTML element. And the second list will be the contents of that element. So in this case, this will be the width of the SVG element, which will be going to be an attribute, and this will be the contents of that.
Okay. So from the language point of view, this width is a function, and where does it come from?
So if you look at the top of this file, there's some imports, and you'll see that I'm importing SVG, and I'm exposing some of these things, all of the things that are in SVG actually, and then there's also svg.attributes, which are I expose all the things, and they come from there. So there's a module that is telling me that the function width has some implementation under the covers that will set the width attribute of the HTML element.
Okay, thanks.
Okay. Other questions?
I'm a bit confused on the, for instance, you see it there in the range.
Yeah.
You say, well, range is a function that takes an integer and then, well, as a Java guy, I would say a list of integers, like as in list with the generic type int. Is that the correct way of saying it, or not really?
Basically, yes. Only the int is not generic. It's actually the type of integers. So basically, what this does, what tells you is, if you take an integer, for example, 37, and return a list of with the which has integers in it. This is basically what it tells you.
Right. A bit lower down, you see the same with SVG.
Yeah.
SVG message. And I find it difficult to understand that one, especially because if I notice correctly, there is no messages being created in your little snippet there.
No, so
is that correct?
Let's go over there. So here, this is an example.
It was the last one, the segment one.
Should we go up?
Yeah.
No, a little bit down.
Oh, a little bit
It's
down.
The last
Oh,
one
yeah,
of the
okay.
screen, yeah.
So this, okay. So basically, how you should read these type signatures is that there's a function segment which accepts an integer and returns a function. So, are you familiar with functional programming?
Yes.
Yeah. So if you're not familiar, what a lot of functional programs do is acknowledging that there are no multiple argument functions. It's just functions that return higher order functions. So this is the case with that. So how I would read this is a function with 4 integer arguments and return something that will eventually return HTML and could possibly update your create a message for that. And where you can see that is a little bit higher up. So there's also buttons that if you press them, that will change. It's not actually in this view. Those things could send a message to your application. So that's how you should interpret that as well. Does that make sense?
It's just that this part doesn't do that, right?
No.
But so does it matter what you type? Like it feels like a generic type where you can have, well, you have a list of integers, then yes, you can only add integers. But if it doesn't matter what things are in there, then well, you might as well not have the generic type. That's the way it feels to me.
It's not a generic type.
Yeah,
it's
it's
a type
a
of
type
structure that
message.
takes a type argument.
It will return it eventually.
Yeah, this word message, does it have special meaning, or is it something that can come up on the fly?
So the message has a special meaning. It's actually defined in this file, so let's look for it. And it are the messages that I defined itself. So it is important because what you're actually telling Elm is that I'm going to create some HTML which will return these things. Could eventually initiate these things, kind of messages. Does that make sense?
Yeah, it's like a list of integers. You will say it's like a list of integers. You can say that a list only contains integers, but you can also have an empty list. Like this is also like an empty list. It doesn't contain integers, but it can only contain integers. So you could also define the type definition as a generic type, which it isn't right now because it's the type of message, but it could. But if he does have a type of message which it returns, then the compiler will say, hey, you defined the type here, so you have to define it as such.
So probably it's best to come down and sit next to me and see what the differences are. But there's a difference between generic type, which the cursor is now on the line with the generic function, which is a list of anything, just a type, and actually a tuple of 2 lists which contain the same type of elements, and it returns that same thing. That's a generic function. It works with any kind of list. Whereas the other list, the list of integer, was actually a list of actual integers. Other questions?
Can I have one more?
Feel free.
Yeah, it has to be a short one.
No, I don't think so. I think
Okay.
we have some time.
Yeah, this can be a far shot. But at the beginning of your talk, you said that you like that you have your model, your update, and your view. If you want to change how things look, you change the view. If you want to change how things behave, you change the update. And if you want to change the model, you change the model, I think if you change the model, you have to change the update and the view as well. Yeah, is that true?
That depends on what you changed. So what Mats also shown, if you add, for example, a color in a type, then if you switch on that type, you need to extend that type to switch as well. So that's certainly true. What I was going at is that for JavaScript applications, if you need to change something, then you need to just search throughout the entire code base. If you're unlucky, to find where should you add or change things to create the fact that you want to reach.
Maybe that of course may be true, but I was actually thinking about Redux, and I just now realized that one of the nice things about it is when you compose your reducers, you actually never define the model explicitly. The model is kind of defined by the reducer. And this is really nice, because I just change this in one place, and I don't have to update my model whenever I change the reducer, which is like an update. Yeah?
I agree.
And with type inference in Elm, is it possible to not define the model and just define update and have the language figure out what's the model?
No, so you actually should have an explicit model, because that's also the thing in the update function. You accept the model and you return a model, so it's not really possible to just
I
figure
also
it
think
out.
it's like lots of people are going to disagree with you when you say, well, it's nice that I don't have to define a model.
Yeah, this
Like,
is subjective,
I
of course.
certainly would hate implicit models.
Yeah, well, I don't think they're really implicit. It's rather like they are defined in the
but
same
can
place.
can I look them up in a single place and say, okay, this is how my model looks?
Well, but it's the same with Elm. Like the model of whole application, you cannot see it in the one place. You have to look at every component. Am I right?
No,
Because it's-
not necessarily. I think at every level you can look at the model and tell, like,
Yeah, so
that's it. There's
I would
no-
say in Redux it's quite the same, actually. Well, okay, it's a very subtle discussion. Maybe not
Yeah,
not going to
maybe
do that.
should
And
take
of
it
course,
offline.
it's subjective.
Take it
So-
outside.
It's an interesting discussion, which is probably best done on a later moment. So, what I've done, I've shown you some code. Nobody really asked questions, but I don't really understand this. Could you explain this? Which for me is a
Can I ask?
a problem.
but
Yeah,
it's
sure.
not like a request, but did you also consider using a ring instead of a list of integers?
No. So
That might be interesting to try.
that's true. So the question was, did you consider a ring instead of a list? No, I didn't. So I just started. This worked, and I called it a day.
What is a ring?
A ring is a list where the end of the list connects to the beginning of the list.
So that would ease up a lot of these functions that are defined. That's true.
Yeah, I think probably implementing the ring would be a lot more work than just. Also would be quite a lot of fun. So
Probably.
I'm going to try it.
So the only thing that I would like to say again are my cons of the experience and my pros of Elm, of using Elm and creating things in Elm. One of the cons is, so one of the advertisements for Elm is that you don't need to look at any stack traces anymore because they just don't exist. And I ended up missing them a bit. So there was, I wrote a complex, in the other project I wrote a complex function that didn't behave like I expected it should. And it really stopped me, and I was like, okay, I really want to debug this now, stop it, and I want to watch the execution state. And that's not really, and at least I don't know a way of doing that. So there's a beautiful interactive debugger. If your application is working, then you should look at that if you don't ever run it. It's like a Mario game. You can stop Mario, you can go back in time, and it's really awesome. It's really helpful. But if your application doesn't start up because it's in some infinite calculation, well, you're just stopped. So that's one thing that I missed. And the other thing is, Elm is a different language. You need to learn it, and you need to get used to it. If you're not familiar of the functional approach, then you need to really wrap your head around it. But basically, those are the cons that I experienced and I really liked. So there are some things, right?
It looks a lot like Haskell to me. So what is the difference with Haskell?
So the type system is not as rich as the type system of Haskell. But under the covers, Elm is implemented in Haskell. So a lot of design decisions that are made in Haskell are seen there as well. I think that doing I/O or doing any interaction with the outside world is easier in Elm because it's for that. So it's really geared towards changing HTML. So it's easy to do that as well. But if you know Haskell, you can read and write Elm with no problem at all.
Also, it's not lazy, so you don't get runtime errors, but sometimes you get stack overflows.
Wait for the microphone.
You talked about debugging.
Yeah.
Do you have something like source maps in your browser that you can put debugging statements in your browser?
I don't think you have. What you can do, so basically, if you look at this example, what I did is I compiled the code and included it, but there's no source map to the actual Elm code. I don't think.
If you ever have to debug the generated JavaScript,
Yeah,
it's
you're.
really, really painful.
Yeah, you shouldn't do that.
Don't do that.
Nothing
Okay.
goes wrong ever, so
Oh yeah, sure.
No, so there's no need for that, I guess. If it's wrong at runtime, Well, Mats promised us that there wouldn't be runtime problems.
I said really zero. I had one in Internet Explorer.
Ah.
A colleague of mine, he set a type of an input to something that it wasn't supposed to be, to just a random string. And that's allowed in many browsers, but it's not in Internet Explorer. So they got a runtime exception when the JavaScript tried to set the type of the input to something invalid. So I just put a debugger to the compiled Elm code, and just inspected some variables and was able to remove the exception. It was that easy, but you're not gonna step through the code. You're just gonna pinpoint that one line, check some variables out to get some context. Probably more you won't need. At least I didn't.
Other questions at the moment?
Is there any way to run it outside of the browser? And I don't mean the server-side rendering, because I mean, yeah. I mean, is there a way of writing non-browser application, like a command line tool, and run it with Node?
I don't think so.
Yes, you can.
You can do that.
Yeah.
So I'm no expert.
And actually, server-side Elm eventually is coming up.
Yeah, no, 0.18.
Yeah, I know it's coming up, but it's about probably more about server-side rendering. Yeah, or
They're planning to do it on method Erlang.
oh,
So it's not going to run on Node.
cool,
You can also write Electron apps with
great. Okay,
that's
thanks.
possible.
Well, okay. Cool. So you should end up with a high. So I'm gonna list my pros. So one of the pros I already mentioned, and that's you know where to change things if you need to change it. So the Elm architecture really gives a handle on where to look if you want to change things. And sure, if you change the model, something's gonna give, and you need to update it as well. But at least you can really isolate things. Like I started out modeling this puzzle in this way and trying to out Elm, and then later on just figure out, okay, now I'm gonna make this. I'm gonna show this in the browser, and I'm gonna this in this way. So you can really isolate the changes that you need to do. That's one thing. Types are awesome. So, like I said, I love JavaScript. Maybe I'm a little bit mad, but these types in Elm just help enormously in figuring out what's going wrong and how to change things as well. So that's a pro. And if you're not familiar with it, then you think, why should things ever be immutable? If you're used to it, it's very nice. So you can really reason about things. You can really take the immutable data structure of your model, reason about what's going to happen, and it's just so it gives you a warm feeling inside. So that's always good, I guess. So this is my talk, my presentation on Elm. I made a puzzle. I hope you like it. If there are any questions, just ask me. Just wait for the microphone.
What?
Last question, by the way, for the next presentation.
What should I Google for if I want to find this puzzle?
Oh yeah, so you should go to fifth postulate /brainbow, and you will get there.
All right, thanks.
No problem.